Algebra II 4.5, Word Problems Using a System of Three Equations. Now, it's really important that you watched videos 4.A, B, and C. It would also help if you watch D, but if you at least watch those three videos before this one, or you understand systems of three equations, you're going to be okay. Otherwise, you're going to get confused, and there's a link in this video's description to see those. If we're going to use three variables to solve a word problem, then we need a system of three equations to find a unique solution. And the system of three equations we find will be a mathematical model of that word problem. This means the equations will be an algebraic version of the words in the word problem. Now, sometimes we'll be able to eliminate two variables at once. Did you know that? And sometimes we'll need to use previously learned knowledge, like squares have 360 degrees inside or triangles have 180 degrees inside, to help us solve these systems. So let's take a look at this first one. We're going to turn the words into our equations. It says the sum of three numbers is 6. Well, we can assign x, y, and z as the three numbers and make it equal 6. So we have x plus y plus z equals 6. I also could have used a plus b plus c, or j plus k plus l. And L is usually not good unless you're using a capital because it's going to look like a 1. But any three variables would have worked. Now it says the difference of the first two numbers plus the third number equals 2. Well, the difference of the first two numbers means we're subtracting. That's the difference. Plus the third number, z, is going to equal 2. So now we have two equations. Now it said the sum of the first two numbers, well, now we know we have to add these two, minus the third number minus the z equals 0. So we have our system of three equations. Here we go. And if you look at these first two, do you see the positive y and the negative y? See that? How about here? Look at a negative y and a positive z and a negative z. See that? So, in this one, what I decided to start with was the green and the blue equations, and without multiplying them by anything, by just stacking them, I could see I've got 2x, and the y got eliminated first. Now, all these videos we've been eliminating x first. It doesn't really matter. As long as you can eliminate one variable and then continue to eliminate that variable, okay, in the other equation. So now we have 2x, the y is eliminated, and 2z equals 8. So now this is our new system of equation. Now we have 2x plus 2z equals 8, and then our other two original equations. So now I pull these other two equations, and I don't multiply them by anything. I just stack them, and I see that we've got a negative y and a positive y, and a negative z and a positive z. I've got a 0 pair here to eliminate the y, and I got a 0 pair here to eliminate the z, all at once, in one move. All I have to do is say 2x is equal to 2. I got rid of all of this in the middle, because that's a 0 pair and that's a 0 pair. Didn't I luck out? Divide each side by the coefficient 2, and I get that x is equal to 1. Now I can plug x as 1 into one of the equations. So I plug it into the green one. So that means I have 2 times 1 plus 2z equals 8. Well, that means I have 2 plus 2z equals 8. Take away the 2 from each side, or look at it as adding a negative to each side, and I get 2z equals 6. When I divide each side by this coefficient 2 by the z, I get z is equal to 3. Well, this is getting easier, isn't it? Now I know x is 1 and z is 3. Did you know that I could substitute the x is 1 and z and 3 into any of the original equations? So I can pick any one of these original equations and put x is 1 and z is 3 into any one of these equations. You don't have to put it into the red one. You don't have to put it into the blue one. It could go into any one. So I chose to put it into the first one. X plus y plus z equals 6. And even though I've already solved for z, the green one, it doesn't matter. So I'm going to put it into this original equation, the x and the z, and x plus y plus z equals 6. Well, if x is a 1, that means 1 plus y plus 3 equals 6. Combine like terms, that means y plus 4 equals 6. I add a negative 4 to each side of the equation to isolate the variable y, and I get y equals 2. So I know my ordered triple is 1, 2, 3. So wasn't it cool that it just happened to be that I could eliminate two variables right in that one center of these and just go straight to 2x? You just have to remember to add both of these x's together to get 2x equals 2. See? Made it very easy for me. All right? Now, let's take a look at this one. It says in triangle FGH, the measure of angle G is 3 times the measure of angle F. So whenever it says the word is, that means equals. So that means G equals 3F. It's 3 times the measure of angle F. So if it's 3 times bigger, that means if you had 3 of the F's, it would equal the G. See? So we have G equals 3F. Then it says the measure of angle H is 20 degrees more than angle F. It looks like everything's being compared to F, isn't it? Aha. So H is F plus 20 degrees. Now we've got our second equation. And it says find the angle measures. Well, what the heck? We've got these two. What are we supposed to do? Aha. Remember, a triangle is 180 degrees. Using that knowledge, we have our third equation. F, so this is our red equation, F plus 20, that's the H one, right? Plus 3F, that's that one, is going to equal 180. We also could have written it as 180 minus F plus 20 minus the 3F will equal F. But it made more sense to put it this way. It all equals 180. So now we have F, we have H, we have G, and we can combine all the F's. We have 1, 2, 3, 4, 5 F's. So 5F plus 20 equals 180 degrees. We add a negative 20 to each side. We create a zero pair here from additive inverses, and we get 5F equals 160 degrees. We divide each side by the coefficient 5, and we get that F is 32 degrees. So now we know that F is 32 degrees. We can plug it in and find G and H. Well, if 3 of the F's equals G, then 3 times 32 degrees equals G. So that's 96 degrees. And if F plus 20 equals H, then that means 32 degrees plus 20 degrees equals H. That means H is 52 degrees. So our ordered pair ends up being, for F, G, and H, we end up with 32 degrees, 96 degrees, and 52 degrees. Sorry about cutting that off there. See? So that's F, G, and H. All right? Sometimes it's hard to write and look and do everything all at once. So, all right? So that's our ordered triple. So by remembering that a triangle was 180 degrees, that helped us write our last equation. See? The goal is just create zero pairs to isolate each variable. All right? Our next video is going to be 4.6a, and we're going to discuss consistent systems of equations. Now, we talked about that in Algebra I. We also talked about it in grade 8 math. So I'm going to have links to the chapters that talk about that, so that if you watch a video of mine and you're still confused, that's why I put these other links in, so that you could see another grade level version of that. Maybe it'll be explained easier or differently to help you get it, okay? It's all going to be in the description of this video, so you can just click on them, all right? See, wasn't that easy? It wasn't that big of a deal to do word problems for a system of 3 equations, right? Just remember previous knowledge, and remember that sometimes, not every time, but sometimes you can eliminate 2 variables at once. I'll see you next video. Bye.